So question 9 then from paper 1 of the 2021 Higher Maths resource paper. 7-mark question, essentially, find the area between two curves. It's been split into two parts. Part A, find the x-coordinate of A, because you need to know the limits of integration, when do you start and when do you stop. And then part B, properly calculate the shaded area, but it's really just the one question for 7 marks. Now one thing to notice here is this enclosed area. It doesn't matter that part is above and part is below the x-axis. That's not going to cancel out in any way. It's not actually the x-axis itself that determines whether areas are positive or negative. It's whether you do it the right way around or upside down. The proper way to work out an area is to get lots of little rectangles, like this, so that the area of that rectangle is solely determined by its height and its width. And the height is given by the y-coordinate of the top, take away the y-coordinate of the bottom. Which means its area would be the y of the top minus the y of the bottom multiplied by its width, and you make them as small as possible. So then it's a little infinitesimal difference in the x-coordinates between these two lines making up the rectangle. And of course the whole area would be just add up lots of these little rectangles, starting here and finishing at A. So the only effect the x-axis has is to determine the y-coordinates. Well, the first part's going to be, how do we get those two limits? Well, it's going to be simultaneous equations. So you can either say y equals y, and then just equate these two parts. Or I could say, I'll put it down this way, I'm actually going to do substitute 1 in 2. Which means I'm going to write down equation 2, but instead of its y, I'm going to write what number 1 tells me to put for y. So I'm going to have x cubed minus 7x squared plus 12x plus 3 is equal to x cubed minus x squared minus 6x plus 3. But you could have them either way around. I've deliberately done it that way around because I'm going to bring this over and subtract it. And in doing that, I'll have done top take away bottom, which is what's required to get the height of these rectangles. So now bringing that over, well, they'll knock out. Unfortunately, it gives me a negative 6x squared, but I can't help that because that's what's going to end up in the integral anyway. Take that across and it'll bump up to plus 18x, and they'll knock out. So I've got this. Now so far, you get the first mark for equating the two equations to get the points of intersection for the simultaneous equations for y equals y. Now I've just got to solve this. So there's not a lot to it. You didn't really, it is a quadratic, but it's got a simple common factor. So I'll take out the negative 6 and I'll take out the x. That will just leave me an x here, but a minus plus, a minus here, a minus 3. Which means I've got two values. You've got x is 0 or x is 3. So when it says what's the x coordinate A, it must be the 3. So I'll just say that. At A, x equals 3. You can always give a reason, because it's the second point. So there's the first mark. So part B, what is that area then? Well, that area is going to be the integral, adding them up, that's the summation sign, the integral from where you start to where you finish, so that's from x is 0 to x is 3 of the top, take away the bottom. Now I've already done that here. So you could just copy that down I suppose, but I think I'll spell it out. So the top was this one, x cubed, even though it's just going to result in that, minus 7x squared plus 12x plus 3 minus, and then this one, x cubed minus x squared minus 6x plus 3. Oh, I'm going to bump into this. Subtracting them gives you the height of that rectangle. Multiplying it by dx gives you the area of that rectangle. Then you add up all these wee skinny rectangles, which means I'll just tidy this up here. But I know it comes to this. Negative 6x squared plus 18x multiplied by dx for the area of that little rectangle there. Now the way the marks went was, first of all you got a mark for doing an integral from 0 to 3 and having something times a dx. The second mark was for having upper take away lower. So I'll put that there. It wasn't a mark specifically for tidying it up. The next mark came when you just integrated it. Now I think I'm just going to integrate it straight and also do the little bit of arithmetic at the same time. So it's add 1 to the power, so up to the 3, divide by 3, but I think rather than showing 6 over 3, I'm just going to go straight in with minus 2. And then x up to 2, divide by 2, and again, instead of writing 18 upon 2, I'm just going to say 9. That's what's going to be evaluated from 0 to 3. That's worth a mark. Now it's just a case of putting the figures. Well, what have we got? Work it out at 3 first. So it'll be negative 2 times 3 cubed plus 9 times 3 squared minus, now you could just put 0 and in the mark scheme you just put 0. But don't just always assume it's going to be 0 just because x is 0. It could be a trigonometrical expression and the cosine of 0 isn't 0. Or it could be one of those functions of a function 1. The type, you know, when you've got the integral and it's something with a bracket, it's acting in a bracket and you've got a linear expression in the bracket, that would be 0. Only the x part of that would have been 0. Maybe I'll just put it all in, just for fastidiousness. Plus 9 times, even though I know it comes to 0. So I can just put that bit in straight away, minus 0. So what have we got for this part? Well, that's 2754, but it's negative. Negative 54. But that 3 squared is 9, 9 nines are 81, so that bumps it up to positive. And if you've done top away bottom, it should always end up positive. Because higher up, take away lower down, always has to be positive. And of course minus 0 from that. Which means finally, for the area of this, it's going to be, well, the difference here is 27 units squared. Now there was a mark for putting in the limits into the calculation, and then the final mark for getting the answer.